Hello, welcome back to another video on the LLM Large Language Model series. Now in this video we'll be doing something more adventurous, which is to download the custom large language model, that's right, have it on your computer and implement the code using LangChain and LlamaIndex to build a summarization and Q&A bot powered by this custom LLM on our own machine. Now if you do not need the natural language response that comes back at the end of this pipeline, you can completely drop OpenAI's GPT and just even do all of this fully offline. For completeness sake, I'll show you how to also use GPT for the natural language response as you query your index, but it's just worth pointing out that you can also just use the embeddings to do the lookup and then use your own custom LLM to generate your response. So this tutorial understandably will be a little bit longer than the usual format, but I'll try to keep it as concise as possible, and you will need to download an LLM from HuggingFace, and I'll show you how to do that. But you want to pick one that can fit into your computer's RAM. And when it comes to choosing an open source LLM, there are a few options out there. And if you've seen my other videos, you've seen me discuss them in my tutorials or having some back and forth in the comment section. The gist of it is that GPT-4 and GPT-3, they're both closed source models and you can't download them and use them on your own machine as you please. GPT-3 has 175 billion parameters, and the largest open source model that I know of is Meta's OPT, Open Pre-trained Transformer, which also has 175 billion parameters as well. So kind of equivalent to GPT. Now in my other videos, I've also used a few other open LLMs, one of it being GPT-2, and that has 1.5 billion parameters. For this video, you can just use any open LLMs of your choice. And initially, I've used Meta's 30 billion OPT, 30 billion parameters, coming in at 60 gigabytes in size. Now I can foresee that it's not very feasible for everyone to be downloading 60 gigabytes of pre-trained weights. And also when I'm doing this recording, it has got some severe lag from the RAM usage by the model, as well as the screencasting application, the audio recording from the mic, etc. So to make things a little bit more manageable for the video, I'll switch to the 1.3 billion OPT model, but the code is essentially the same, just changing 30 billion to 1.3 billion. For the code on GitHub, I'm still going to publish the one with 30 billion. So if you want to go to GitHub, fork the entire repository to follow along this entire series, I think we are on like video number 6 or video number 7 now, then you can do that. Alright, let's get started and let's code this up. So open a new file wherever you want that file to be. I'm going to have this on my desktop, so demo9.py, and this will also be on GitHub. Some of this scaffolding become quite standard. You can just go ahead and say from.env import load.env, and you can just load it in. This will just look for a file called .env file, and it would just bring in everything in there. So your .env file would contain your keys and stuff, right? And it would just load all of this in here. I also want to be using, let's bring in from LlamaIndex import. So let's go with prompt helper. And this prompt helper, this utility helps us fill in the prompt, split the text, and fill in context information according to necessary token limitations. So if you've seen my other videos, you know how I talk about this context, right? You set up a context and you pass it onto your LLM. It would be a really useful tool to have, so I'm going to bring that in. And I want to bring in my directory reader. So do a quick formatting, bring this up. And you'll probably be wondering, say, Sam, I've never really seen you use prompt helper before. What is the point of that? Well, so this is useful in this demo because we're trying to use the prompt helper to customize the prompt sizes, input sizes and stuff, because you're going to be using your locally hosted LLM, and every model has slightly different context length and stuff, and so you want to at least have control over that. And when you're using OpenAI GPT, for example, you know what the output would be, you know what the input would be, but here you're going to be using your own self-hosted LLM, so this is a nice way, a nice interface to just sort of control that. So let's set it up, prompt helper. It initializes a couple of things. So for example, I can have my maximum input size. I would first set it to 1024. If you're using the DaVinci model, the default is 4096. So here I'm trying to set certain constraints. I'm saying that the maximum input size is only, I only want it to be this size, for example. And I also want to change the number of output. So I want to have that as some other figures. Of course, the default is 256. So this is the number of output tokens, and it's usually set to some pretty low number by default. For example, if you're using OpenAI, the default is 256. You can change this up to maybe 512. You can bump this up to 300, whatever you have. Okay, so this is the number of output tokens. So for now, let's just stick with the default, but we can change it later once we run the model. Last thing I'd like to change is the max chunk overlap. I'll set it to maybe 20. Alright, understand that this is actually the maximum. It's not saying that, okay, force the chunks to overlap. You're trying to create all these chunks, but then you're saying that they can have a bit of overlap, but the maximum of that would be 20. It's usually nice to have a bit of overlap. Nice to have some overlap to maintain some continuity between the chunks. If you're familiar with computer vision or you do some sort of deep learning in the past, you could think of it as an equivalent of a sliding window. So you want to have some sort of overlaps between the chunks to maintain some form of continuity. Probably you won't need the comments, you're just going to remove that out. Okay, now how do you actually implement your own custom LLM? For this, we need to bring in this base class that we inherit from. So we're going to say from LangChain.LLMs.base import LLM. Okay, so we're using Llama to create the index, and then we're using LangChain to create our LLM, and this will be a custom LLM. So you'll have something like class, and then you say this is your own. I'm going to be using OPT, the Open Pre-trained Transformer model by Facebook. So if you want to use something else, you just have to change this. I'm going to call it local OPT, because to remind myself that it's a custom LLM that I'm implementing. And the first thing you want to pass in is a model name. So we could have a model name. Now, I said earlier that if you want to use a pretty high performance model, a model that has pretty similar results to GPT-3, for example, then you want to use the whole OPT model. GPT-3 has 175 billion parameters. We spoke about that at the beginning of the video, and OPT has also 175 billion parameters. Pretty equivalent. You can read about the papers, I'll link them in the description. But in case if you don't have hundreds of gigs laying around, hundreds of gigabytes laying around on your computer, then you may want to consider a smaller model. So a pretty good trade-off is to use something like Facebook OPT-IML max 30B. Even this is a 60 gig model. Even this is not a small model at all, right? So this is the OPT-IML max 30B. It's relative, right? It's pretty small relative to the GPT-3, the large ones, but 60 gig is not something that I'm running on a Linux box. I have enough RAM, I could run this, but when I need to record it along with the video editing and all these other things running and competing for the same RAM, then it gets a bit laggy. So I'm probably going to switch one level down during the recording of the demo, and then I'll push the code up with the max 30B. And also note that I'm not using the OPT, I'm not using the OPT model, or I'm not using the Facebook OPT model, I'm using the OPT-IML. If you want the URL, it's huggingface.co/facebook/OPT-IML max. And what does IML means? It's instruction meta learning. So OPT plus instruction meta learning is a set of instruction-tuned versions of OPT and on a collection of more than 2,000 NLP tasks gathered from 8 NLP benchmarks. And you can read about the limitation and the biases. OPT-IML models outperform baseline OPT on an extensive set of evaluations, but it has its own risk of generating maybe things relating to factual correctness, generation of toxic language, and forcing stereotypes. But what is instruction tuning generally? It's actually the act of getting humans to use natural language instructions to guide the language model, to generate a specific task or outcome. So using natural language to sort of guide it, prompt it, and with the goal of trying to induce what you hear as a zero-shot capability. So where the model can actually generate a specific output without any kind of training data. So for example, you have a sentence like, Supertype is a great company that gathers the top software engineers in Indonesia to build full-stack machine learning powered applications for the world to use. Okay, that is a useful sentence. But if you want this model to output, let's say, a sentiment, right, to do some sort of sentiment analysis, then you want to slightly help the model by giving it some more details on the task, and this task instruction may look like this. You say that Supertype is a great blah blah blah, but how does the reviewer feel about Supertype? You want to prompt this, you want to say that. Then you want to give this LLM a pool of options. Tell me whether this is positive or negative or neutral. You specify all of this in natural language in your instructions, and to get your LLM to only pick one of these options. So instead of just putting in a big blob of text, you give me this blob of text, and then you're trying to give it further instruction and say that, hey, tell me if the above review sounds positive to you, negative to you, or neutral, and only pick from this pool of 3 choices. A good resource to actually learn more about this, you can take a look at this PDF. I'm also going to put a link there in my description. So instruction tuning fine-tunes a language model on a collection of NLP tasks described using instructions. Here's the review, blah blah blah, the movie is the best rom-com since Pretty Woman. Then you tell the prompt, you said, hey, did this critic like the movie? And these are the options, yes or no. And you keep doing it, you keep doing it. So for example, if you want to do sentiment analysis, you should keep showing it, and you do, like 10,000 of them, 20,000 of them, and ask it to ask the LLM to sort of pick up this behavior. If you want to do something like question answering, then you say, oh, what is the this guy's profession, and you give it an output, and then you give it some sort of choices. Same thing here, you give it some choices, rule-based tasks. So that is instruction tuning in general. I'll leave all of these links somewhere in the video. Once you pick the model, pay attention to what kind of tasks are there. So here there's the text generation task. Then go back to your editor. Immediately I could create my pipeline using a utility from transformer. So I'm going to bring that in as well. I'm going to say from transformer import pipeline. Now I'm just going to have my pipeline. And remember the task I told you to just pay attention to. So that's text generation. So I'm going to call it text generation here. That's the task. And then you give it a name. So this would just be model name which we define above as a variable. If you want to pass in a few more things, you can. There are a few optional parameters. I'm going to show you that really quickly as well. I can maybe just do, but these are optional. So I'm going to maybe space it out a bit. Could have my device running using my CUDA. So that's my GPU. You can omit this if you don't have CUDA set up. And if you don't know how to set up all of this, I have videos on that. It's part of my whole GPU deep learning series using PyTorch. So you want to learn more about PyTorch. You want to learn transformers, then you need to learn PyTorch, right? To use PyTorch, I have a whole series about that, teaching you about setting up your NVIDIA, downloading a driver, all of this stuff. So go and take a look at that video. And then finally, you can have some optional model parameters as well. So for example, you could have torch, and you can say what is the data type look like. So if I want it to be a 16-bit float number, I could have that. I could say bfloat 16, and that's coming from torch. So I will need to bring in torch. Maybe here I'm gonna have to say import torch to torch bfloat. Just make it a bit more efficient and do some formatting. Don't want to miss out your commas. Okay, the usage pattern of this, because this is a class, you initialize that, right? You say something like LLM equals to local OPT, and you call it like that. So what happened when you call it? You didn't really say what you wanted to do. You only defined the model name and the pipeline, and the model name is actually going to be used in here. So what do you want it to do when you call it? So this goes back to OOP basics, right? It's like, what do you want to do when somebody call it like that? So you want to define a call method, and it takes two things. It takes the prompt, and you can pass it a stop. And stop could default to none. If you want to add some typing, you can say prompt. I want this prompt to be a string, just to make sure that the user knows from looking at this code, they know what to do. So I'm expecting a string, and I'm expecting a stop, but this could be optional because there is a default of none. And then it should output what? It should also output a string. So you could also add some typing to the output as well, and say this output the string. So it takes a string, an optional stop, and it outputs a string. Create a response variable, and you say take the pipeline, which is up here, take this and pass in the prompt, then pass in some max new tokens. This, you should want this to be the same as the one up here. You know what we can do is to maybe have a max token and set as 256. Then you could just, instead of hard coding this, set this up. It's going to return an iterable, so you want to only take the first item, so I'm going to say 0, and among that item, I'm also going to just take the generated text. But I will show you what happens if you don't do that. It's going to give you a bunch of things. It's going to be too much. I only want to get the first item and then get specifically the generated text key. So now you're only returning exactly what you want. But this will also include the prompt itself, right? So for example, in the earlier example, use some examples here, right? Is a data science consultancy. Write me and add copy for their website. Okay, seeing that this is going to be text generation, it is going to have all of this text in the return, and then it's going to generate new text after that. So one way you could sort of get around that is to just do an indexing on this string and just remove the first and characters. And to do that, you can just say return response, and you say, well, this is called subsetting or indexing, right? Say take from the length of the prompt all the way to the end. So what this is going to do is going to say, okay, whatever the length of this is, if the length of this, let's say this is 63 or 62, right? Take 62 and then move from there all the way to the end, meaning just ignore I don't need to repeat to me the prompt, right? That's what it's trying to say. So you can add a comment here. If this is getting a bit much, you can just add a comment and say, this is only returning the newly generated tokens without the prompt, or whatever, right? You can say that. Two more things to sort of complete this local OPT class, and that's both things are property. So the first one is property, and this is a private method identifying params, and you want to return, say, name of the model, and again, this is going to be self.model name. So this is better than to hard code this and repeat this everywhere. So you don't need to copy this and paste this everywhere. You just have to define a variable, kind of like what we did up here, and then just reuse it. Then you want to have a second property, and you want to tell your code that this is a custom LLM type. So just have to return custom. So this tells the code that this LLM type is a custom LLM. Okay, I could start to write the code here, but to keep things nice and tidy, all in its own functions, let's go ahead and create another helper function. We call it create index. Right, so define create index. And this is where this function is going to be responsible for creating an index. For creating an index. So I'll need two more things here. So I need to go all the way back up here. It's going to be a bit long, so space it out, move this down. I will need an LLM predictor. This is a wrapper around an LLM chain from LangChain, right? So we've seen a lot of demos in LangChain. We've seen how we can basically the whole idea of chaining things and then agents and stuff, right? So this is a wrapper around an LLM chain. So let's use that LLM predictor. Sounds good. Then we also want to bring in service context because we want to have another interface that acts as a container to contain the predictor, the prompt helper and stuff. So if you read the help text here, it says the service context container is the utility container that holds all of this together. So holds your LLM predictor, that's going to be this one. And it also holds this prompt helper, which is something that we bring in as well. So might as well bring it in, close it out. And I know I need to create an index, so I will probably also bring in my GPT list index. Then we can go back down to where the create index is. And let's first use the wrapper around the LLM chain. This is a wrapper around the LLM chain from LangChain. Let's say LLM predictor. And here is the same as what we've done before, which is to just call it. And then remember we talked about the service context. So act as a container for your LLM index and for your query. So let's bring that in. Service context. From default, we have our LLM predictor, and that would just be our LLM that we created up here, right up here. And we will also have a prompt helper, and this is also something we created right up there. So if you look at the prompt helper, that's here, and the LLM, that's this one. And if you want to read more about the service context, you can look at the documentation. I know nobody actually want to look at documentation, but the service context container is a utility container. It contains the following objects: the LLM predictor, the prompt helper, all of these different things in here. So you can, I'll put a link to that as well. Now you have your LLM and you have the prompt. So what else do you need? You need the index. But where does the index come from? It comes from your documents, right? You have the documents, you create the index using your documents. So let's start to do the docs and let's do the index. So docs. This is something you've seen me done countless times before, so it's just a simple directory reader. Where is the directory? It's gonna be in my current directory. It's gonna be called news. So I will just have to specify news. And then I just have to say load data. That would load all the data into the docs. And then creating an index is also really easy. You've seen me do this before as well. So that's gonna be index, let's say GPT list, index, from documents. And you then pass in like where the docs are from. So I'm gonna say docs. Okay, that's the one up there. Give it a service context. Sometimes this could take a while depending on how big your data is. So you could maybe add some timer function up here. You could also maybe print and say this is starting to create index. And bring it down here. And we're gonna say here done creating index. Of course you want to return the index. If not, there's no point doing all of this if you don't return it. And now you could say if name equals to main is index equals to create index. When you call create index, it's going to run this code, it's going to return an index, and you take that and you pass it into a variable called index. And then now you can use the index to do some query. So you can do some query. You can call this response. You can try to summarize I don't know, Australia's coal exports in 2023. Then you can print response. Okay? And that is it. That is kind of the simple barebone structure. Now if you want to improve on this a little bit, you can try to maybe have some timer functions to make sure that the calls are not too long, especially if this model is going to be pretty huge. This model is, if it's a 60 gig model, it's going to take a while, depending on how fast of internet speed you have, but it's probably going to take up to 40 minutes, one hour maybe even. So if you want to just add those things in there, you can do that. I'm going to do that for you as well. So I'll bring in import time. And on my machine, I actually have a nice utility decorator that I put into my clipboard that is there to just time functions. In one of my videos, I show you how to do that, and if you're interested in learning about decorators and stuff, you can definitely go and check that out. But this is my helper function. So the helper function is just called time it. And the way you use the decorator is to just call time it like that. You just wrap the whole function in there. It runs time. It executes the function with the result. Then it prints the time that it takes from the end to the start. Then it prints the result. Doing the query is not going to be very long, but if you want to, you could also have that as a separate function. Just have a helper function called execute query. Can have response, index query. Basically just the same thing as this one, so might as well just copy this and then return response. Now this could be rewritten by just calling execute query. Then you can print your response here. I'm gonna comment this out and maybe use this one, bring it down. So with the query, you can do a couple of things. You can, for example, use the exclude keywords to maybe speed up the process a bit, and by telling him, okay, if any of the nodes contain any of these keywords, just ignore that completely, right? So you could use maybe, in this case here, I'm asking about coal exports. For this demonstration, I'm going to say exclude petroleum every time you see the word petroleum. I could also say maybe exclude if you see the word gas, right? Or oil or whatever. So I could have a list of all the exclude keywords, and this is going to actually say, well, among all of these nodes in the index, right? If the node contain any of this words, just exclude it. So you could maybe speed up the query a bit. You can save yourself some money, save yourself some time. The opposite of exclude keyword is to have the required keywords. So you could say, well, I'm asking about coal, so clearly I want that, right? But a lot of these are all optional. You can have that, you can choose not to have it. So I'm going to comment that out. Since I'm asking about petroleum, I want to put a question here that maybe, I could maybe ask about this. I said, who does Indonesia export its coal to? Right, could ask that question, and I said exclude the keyword petroleum. Alright, so with the combination of using exclude keywords and required keywords, you can preemptively filter out nodes that either do not contain the required keywords terms or contain exclude keywords terms. So you're trying to just reduce the search space and save some time, save some cost, and just make this query overall a little bit faster. Since we already have the time it, we will also apply it here. And I also want to mention about this, since we're talking about this index to query. Sometimes you do not want to have the text return. You just want it to tell you, okay, which docs to look at, or which is the node to look at, and then you can generate your own text. So in that case, you can also say response mode, and you can specify you don't want any text back, so no text. So it's not going to try to generate a nice natural language response back to you. It's just going to generate no text. I'm going to show you how it works once we save all of this. One small thing I'll do before I start to run all of this script, the demo 9 script, is I'm going to go back into the local OPT, but since I'm just trying it out, I will change this, so I'm going to comment this out, to the 1.3 billion. And this will bring it down, so I'm not trying to, because I'm still in development mode, I'm trying to test this out. So if I'm trying to run this with a 60 gig, it's going to be very heavy, it's going to take a long time. So I'm going to change this down. 1.3 billion is a 2.63 gig model. So substantially faster, should be a lot faster, should be at least maybe 25 times faster. And to save myself even more time, I'm also going to use the OS to say that, hey, the first time it's running, go ahead and create the embeddings, put it there locally, and then from there on, just use the cache. Right, so I'm going to say import time, then I'm going to say import OS, then go all the way down, push down to the end of the file. Then I'm going to say something like if not os.path.exist. If this doesn't exist, and this is demo 9, so I'm going to say demo9.json. If this embedding is not found, then I'm going to print and say no local cache of the model downloading from HuggingFace. And just to tell the user to be patient, it's going to download from HuggingFace, it's going to take a while. Then I'm going to move this in, say go ahead and create the index. Then say index, save to this. Save it for demo9.json. In fact, since I'm already repeating myself, a better thing to do is to just sort of define the file name and then say this is demo9.json. Here you can change it, so quite file name, same thing, quite file name. So try to not repeat yourself, right? So that you don't make any mistakes. Also, it's better practice. If this cannot find anything in your local path, it doesn't find the demo9.json, then it's going to go ahead and run it. But if it does find it, then it's going to save you some time. Gonna implement our fancy cache, and it's going to say print loading local cache of the model, of the embeddings actually, not even the. So this should also be called embeddings, or you can call it index. And then here you say index, and this will just be the same as this GPT list index, but instead of the from documents, you say load from this. So using found name, no repeating, no need to copy and paste. Now we can save all of this, clear the screen, and I could run demo9.py. And sure enough, it does create the demo9.json for us. And if you click onto the JSON, you can see this. And the reason it's a little bit faster for me is because this model is somewhere on my computer, so it finds it and it just uses that instead of trying to re-download from the internet. That's your index. All of this stuff like index, for example, summary. I've explained all of this in my other video, the embeddings video. That's a little bit of a 30 minutes video. It goes into a lot of details about how this is done, what is the logic of that. So if you want to read more about this, you want to study more about that, go and watch that video instead. I'm not going to repeat myself in this lesson, alright? So if you wonder like what does this do, go and look at my other video, the embeddings video. So let's go back to demo9.json. Now we see that demo9.json is created. And you say, but what is the point of having response mode no text? So no text basically, it doesn't try to generate a natural language to try to answer that question. And here is when you can chain another language, LLM. You can use the same LLM, you can chain another LLM to handle this downstream process of saying that, okay, now that you have the index, you can query that. And you said no text, but use your own LLM to sort of query that. So let's get back in here, right? And I'm going to remove the response mode no text. Now it's going to generate some text. Now it's going to use the OpenAI token to generate some text. So I could expect some natural language response to this question. So I'm going to save that, run demo9.py. And this time it should be faster because it should be able to find demo9.json. It says, hey, it does exist. So it's just going to load the cache. So sure enough, it says loading local cache of the embeddings. And it says that Indonesia is the largest exporter of coal globally with a 32.2% share in 2022. You can quickly do a Google search to verify that information. Largest exporters of coals globally. And if you read some news that are quite recent, let's say this is November 2022, this is like 4 or 5 months ago. Indonesia exported about 478 million metric tons of coal, making it the world's largest coal exporting nation. And then Australia is the second largest exporter of coal. So Indonesia, Australia and Russia, they are the main providers of coal worldwide. You can see it's doing a pretty reasonable job. The first part of this response is a bit confusing though. It says Indonesia does not export coal, but then it says that it's the largest exporter of coal globally with a 32.2% share in 2022 and its main exports destination are Japan, India and China. Alright, so what's up with the first one? So I have my theory. My theory is that because this data itself is collected over the last 2 years and it's a very small snippet of that, the entire photo will be so much larger. But there is a coal export ban in Indonesia. There is a ban of coal export. There is a very temporary ban just to prevent until the domestic needs are met. Until then, you shouldn't be able to export coal. So that may have confused the LLM a little bit. And you can tune this a bit. You can change this stuff and also adjust the prompt helper there. Maybe have a bit more. Change the chunk overlap. Change the different input size, the output. So I'm gonna maybe just change this to 5.2. Now up to this point we've been doing a lot of Q&A, so let's change this up a bit by actually having a summarization task. So let's copy the summarized task here, comment out this, summarize Australia's coal exports in 2023, but I also want to pass in a response mode. I want to say that this is a pre-summarized task. Okay, nothing else changed, save all of that, run demo9.py. So it's building index from 2 chunks, from nodes, right? 2 chunks. And let's see what it says when it's done running this. Okay, let's bring up the terminal a little bit more. So you realize that this is the number of tokens you're using, this is the number of embedding tokens, and it's going to be 0 now because it's just going to use the local cache of embedding. So it's not really generating new embeddings again. It's just trying to generate words for you, right? So now it's generating the whole words. And you realize that my text is much longer because I've changed the max output as well from 256 to 512. So let's go and take a look at this. In 2023, Australia is expected to experience a decrease in coal exports due to the adoption of alternative markets by China. Despite this, coal exports are still predicted to reach 128 billion in 22 and 23 and relations between China and Australia have mended, allowing for coal shipments to resume. So if you remember, there is a small episode between China and Australia where they start to hand out some trade bans and stuff against each other. So the relationship has a little bit warm. But you can also continue reading. Japan is the top export destination for Australia in 2021, while exports to India rose by 13.6%. China is projected to be the largest coking coal buyer from Australia in 2023, with total shipments for coking coal imports expected to have a minor increase due to imports growth from Australia and Indonesia. And does it summarize everything? It does summarize pretty well, right? If I'm a very busy executive working in this industry, I just want a quick snapshot of what's happening in the industry. I could rely on this. Of course you want to fact check all of this stuff. You want to, especially when it comes to numbers like 128 billion, 13.6%, you want to fact check all of that. But it does a pretty reasonable job. So there is the Q&A use cases like this. There is the summarization. You can also pass in no text. If you pass in no text, then very likely what you want to do is you want to say something like print response, and you want to print the source notes. Response, get formatted sources. You may want to print this too, because if you print source nodes, you're going to see, okay, which is this information that is generating for you, right? This information is generating, which is the source node that is getting the information from. So maybe you have 500 nodes. Which one of the node contain the information, right? We talk about all of this in embeddings. If you haven't really had a exposure to LLM in general, I recommend you watch that video. It's going to give you a right foundation, and then this will make a lot more sense because we dive into all of these different ideas there in that video, right? So source nodes, you can, if you wonder where it gets this information from, you can take a look at some of this. So I'll end it with some further resources you can go and take a look at. So the first one is this video. Now the thing about this video is that it's in Mandarin, it's in Chinese. So if you do not understand Chinese or Mandarin, you're going to have a hard time understanding it. But some of the slides are pretty self-explanatory. So like this is one of the slides, slide 28, instruction tuning. I went to Jolene's concert last night and I really love her songs and dancing. It was. Now here you're giving some instructions, but you're prompting it in English, in natural language. You're saying that continue to fill up this, but using one of these three options, positive, negative, or neutral. You're trying to tell it, trying to teach the LLM that you're expecting a response from this tree, from this pool of choices, right? So depending on how much time I have over the next few weeks, I may create some videos that dive into these concepts and explore LLM on a more theoretical, less coding, but more conceptual level. But for now, I hope you enjoyed this series. I hope you learned something new. If you have any questions, feel free to leave them in the comment section. I'll try to answer them as best as I can. Have a nice day. See you.